Number 5 is going to have you do implicit differentiation. To do that, whenever we take the derivative of something that has a y, we have to put dy dx, because this time we don't know what the formula for y actually is. So we're taking the derivative with respect to x, but we get to a portion with a y in it, it turns into a dy dx. Now on the left-hand side here, that's going to require you to use a chain rule. So the derivative of cosine is going to be negative sine of xy, but then, because it's chain rule, we have to now take the derivative of the inside. Now when you do the derivative of the inside, there's two different variables here, so that's going to require the product rule. So this is kind of a chain combined with a product. So let's do that next. We have the first, and then we're going to do times the derivative of the second. Now when we take the derivative of the y, that's dy dx. So dy dx. So first times the derivative of the second plus the second, which is y, and then times the derivative of the first. The derivative of the first is going to be a 1. So this whole thing is going to be the derivative. We have the derivative of the outside, derivative of cosine is negative sine, and then all this is the derivative of the inside there. So this whole thing is the derivative of the left-hand side. Now we have equals. Now we're going to do the derivative of the right-hand side. The derivative of 1 is 0. The derivative of sine is cosine, but again, this is a chain rule. We have to also multiply it by the derivative of the inside here. So that's going to be a dy dx. So don't forget about the dy dx on this side. That's going to happen also because this is a y. If that was just an x, we would just have cosine x, and that's all we'd have to do on the right-hand side. But because it's a y, that's why you have to put this extra dy dx. Now, the next thing we want to do is multiply this out to get rid of the parentheses, because ultimately we want to get all the dy dx's on one side of the equation. So in order to do that, we have to kind of free this one up by multiplying both of those. So doing this one, you're going to get negative x sine xy dy dx, and we're going to have minus y sine xy, and then we have this over here. Okay, so that's the next step. We distributed both of those all the way through to get this. So now we want to get all of the dy dx terms on one side of the equation. So we're going to take this cosine over here, and I'm going to subtract it over, or you could also add this one. Whatever you want to do is fine. Let me just bring that one over and make them both negative. Now this one here will become positive when I move that across the equal sign. Okay, so now we have all the dy dx's on the same side of the equation. The reason for putting them all on one side is because you want to factor out a dy dx next, so that way you can solve for dy dx. So with that, I'm going to go up here and kind of rewrite over this so we can solve for it. It's basically going to be, next step is factoring. So dy dx we're going to factor out, and we're going to put these two things in there, negative x sine y minus cosine y, and all that's going to equal the right-hand side. Okay, so you want to factor it out to get to that point. And then once you have it factored out, you're going to divide both sides by what's inside the parentheses, and that's going to give you dy dx. So now, hopefully you have all this. If not, you can always rewind it. Let's erase all this so we have some space to get the final answer. Your dy dx is going to equal y sine xy. We have negative x sine y minus cosine y. You can leave your answer like that. If you'd like to just distribute or take out a negative sign from both of these, factor one of those out and just put a big negative outside and have a plus down here, that's fine as well. Not necessary though, this answer is sufficient as is.